Chapter 5, the second part of Chapter 6, will have to do with equations that involve inequalities. This time we will be working with the two variables, so we will look to see what special considerations we'll need to use as far as inequalities. I am doing this with using my mouse pad on my computer, writing with my finger, so you'll have to bear with me, but it seems to work better than what our interactive board is working at this time. So first of all, we start out with a linear equality, and we have x and y in the inequality. Again, those could be any variables. Sometimes this is more confusing the way that they're saying it, but they're saying a coefficient times x plus a coefficient times y is less than c. That would also work in the other equations then. And it says an ordered pair x and y is a solution of the linear inequality if the inequality is true when the values of the x and y are substituted into the inequality. Let's put it into action so that's not so wordy. So it's asking you to look at this equation, 2x minus 3y is greater than or equal to negative 2, and see which one of these are actual solutions to this. What you're going to do is, with each one of the ordered pairs, you have an x and you have a y, and you're going to substitute those in to the x and the y in the equation to see if it is a true statement. So the first one would be 2 times 0 minus 3, substituting in the y value, which is also 0. And you're going to say, is that greater than or equal to a negative 2? Well, 0 minus 0 is 0. And is 0 greater than negative 2? Yes, it is, because it's to the right of it on the number line. I'll show you those number lines in just a second. Let's go ahead and solve the next ones. 2 and my x in letter B is 0. So 2 times 0 minus 3 and my y this time is 1. Is that greater than or equal to negative 2? 0 minus 3 would be negative 3. And is that greater than or equal to negative 2? That is not. So that one is not a true statement. And then if we look at the next one, we have 2 times 2 is my x value, minus 3, careful with your integer here because it's times a negative 1 is my y, and is that greater than or equal to a negative 2? This would be 4. Negative 3 times negative 1 is a positive 3. And greater than or equal to negative 2. Yes, 7 is to the right of negative 2 or greater than or equal to negative 2. And I did a little cheating here, and we'll use this to show how we're going to graph that inequality. You'll see on the graph that you can identify each of the coordinate points that were listed up here in A, B, and C. And then we went ahead and we graphed that, knowing our, you can put that in slope-intercept form or in standard form, finding our slope there. And then we would shade to the right of it, and that is where our two solutions lie. But our one that did not work is on the left side, the not shaded side of the equation. I would pause the recording and read the little paragraph as well to see if that makes sense to you. Here are the steps of graphing a linear equation. You'll notice you have a new term about planes because you will be using the full grid and not just a number line. And you will be shading appropriately with that. Maybe not. Continuing with how to graph a linear inequality, when you find the solution to the inequality, as in right here, x is less than a negative 2, you'll notice you cannot just use the number line any longer. So a couple things I'll point out. All of the rules are stated here. This is straight from the book. Because it's a less than sign, and not less than and equal to, you'll see that we have a dotted line, and it is located at -2, as the answer is here, and then shaded to the left. Again, shading will match the inequality symbol if the variable is stated first. Again, you may wish to pause and read each of the steps to how to graph that inequality. Pointing out a couple details in example 3, you'll notice that it's using a less than or equal to symbol. So we have a solid line. And then this time, because it is a horizontal line, less than would appear underneath it in a coordinate plane, shaded in that manner. Again, pausing and reading each of the steps should make sense. So example 4 would leave us with writing it in slope-intercept form. So we could use the equation right now is in standard form. We want to switch it to a slope-intercept form so it's easier for us to graph. So slope-intercept, I'll rewrite it here. Again, I'm writing with my finger, so be nice to me. Y equals mx plus b. B is the constant term. Y and x with a coefficient, if either one of those could have coefficients to them. So I'm going to rewrite that equation with y on the left side of the inequality symbol. I'm just rewriting it first. Okay, just copied it over. I want to get my y term by itself. I'm going to put a big equal sign there like you should get used to doing. X minus x cancels out, leaving me with y on the left side like I'd like it to be. I keep my inequality the same. I do not multiply or divide by a negative. I'm going to write my x first to put it in slope-intercept form. And then it's a positive, so that's my operational sign, 3. Again, that's my b. B means it's my y-intercept. Math 1 is looking at me like I'm crazy right now because I'm talking to the computer. So I would find the y-intercept right there is 3. I'm going to actually mark it with my pencil right now. And then get rid of all that recording. Okay. And then I can go ahead and graph my line. I know my slope is a -1. So over 1 and down 1, or to the left 1 and up 1. There's how I'm graphing that equation in slope-intercept form. And then the shading that you learned in the last lesson. Hold on 1 second, guys. I'm going to pause this a second because this class would like to go to lunch.